Hey, 8th graders, today's assignment is called What is Matter, and it's really going to get us started into thinking about chemical reactions. We're going to learn a little bit about, obviously, what matter is, and then different ways we can organize matter and how we can identify matter based on its properties. So really this is helping us start to talk about chemical and physical properties, which when we start to look at chemical reactions, we'll see changes in those chemical physical properties as we change from one substance to another in a reaction. So again, this is kind of our jump off point for this unit. Your learning target for today, I can identify matter and its properties. All right, so to start you guys off, I want to kind of just test your guys' knowledge and see what you guys think you know about matter. So this is a little matter inventory checklist, and below you guys have a bunch of items listed. And you're going to go ahead and read through them, and you'll use your draw tool to mark whether or not you think they are matter. So if it's matter, you guys are going to put a little X next to it. So rocks, you guys might think rocks are matter, so you guys would put an X there. If you guys don't think it's matter, you're just going to leave it blank. Okay, so go ahead, take a second to do that, pause this video as you need, and then we're going to go ahead and move into our next little part where we actually learn a little bit more about matter. All right, so moving on to slide 3, you guys are going to watch this video right here, so you're going to go ahead and right-click the link, open it up, and you're going to watch this little crash course video called What's Matter. So you guys are going to learn a little bit about what matter is, and then you guys can go back in and redo your matter inventory on slide 4. So this is a new matter inventory. You don't have to fix your old one. Just use what you learn in that video to kind of reassess. You might have had some marked that should not have been marked, or you guys maybe didn't mark some that should be marked as matter. So again, use those definitions of matter that you learned from that video to kind of redo your matter inventory right here. All right, next we're going to learn a little bit about chemical and physical properties of matter. So you guys can right-click, open this link up, and you guys will get this little video called Physical and Chemical Properties from Chem Academy. It goes through a lot of the physical and chemical properties that we talk about class, but we're going to talk about a couple more as well. So you guys will have to do a little bit of research on that. Okay, but pay attention to what a chemical property is versus what a physical property is, and what are some examples of those properties, and how can we use them to identify matter. All right, next we have 2 slides where you guys are going to do some matching on chemical and physical properties. So what you guys see is we have a bunch of physical properties on slide 6 that are listed in green, and they are improperly paired with their description or definition or however you guys want to talk about it. Example. Okay, so for instance, density is not the temperature at which a liquid turns to gas. So some of those, again, were listed in this video. You guys can get their correct definition there. Some of them you might have to Google. So for instance, I know density is how much stuff makes up an object. So the scientific way of putting that is how much mass in a certain volume. Okay, so if we're looking at a ball, you guys might have a really lightweight ball that doesn't have a lot of stuff crammed into it, or you guys might have a really heavy ball that's the same size but it's made of metal, so it's more dense, it has a higher mass for the volume of that ball. Okay, so I'm going to go through and find the correct definition. It's right down here. How much matter is in a certain volume? So I would grab that little definition, I would move this definition off to the side, and then I would place that under density. Okay, so go ahead and correctly match those up. For the last time, if you guys haven't, if you don't know what they are, some of them are common sense, some of them you might have to Google. Make sure you guys look those up. Okay, chemical properties, there's a lot, but there's only a couple that I want you guys to know about. So we have flammability, radioactivity, whether it's explosive or not, reactivity, toxicity, and corrosivity. Okay, so you guys can look at those and match them to their correct definition. Again, some of those are from the video, most of those are from the video, some of them you might need to look up or use some common sense. All right, next you're going to move on and watch this video, which talks about how matter can be changed so that it can have different properties than it did before. So this would be looking at something like, all right, here's a piece of plastic, it has these physical properties. How can we change that plastic to maybe make it stronger? Okay, we change its physical properties. So watch Material Magic, Making Diamonds. And then you're going to go ahead and watch this one here. It is one from Nanospace, and it looks like this. Okay, you're talking about, again, material worlds, why certain objects have the properties they do. So if we're looking at, it looks like he has 3 balls here. If we were to look at the physical properties of those balls, why are they so different? Okay, what happens on the atomic level that makes them so different? Okay, so answer these questions. Why did the plastic ball bounce higher than the ceramic or the plastic ball? I need to fix that one because there's definitely an error there. Materials have different properties because of the blank they are made of and how they are organized. One property of metals is their malleable nature. How are different metal atoms arranged that make them malleable? If you guys remember from earlier, malleable means we're able to change its shape. Okay, whereas something like ceramics, they're hard like metal, but they're not malleable. We can't easily change their shapes once they're cooked right. Okay, if you know anything about ceramics. And then polymers are very blank that have a carbon chain backbone. Okay. And then you guys are going to follow this little link right here. You're going to right click, go into nanospace. Looks a little something like this. You're going to proceed to nanospace and then follow the directions. Go through the door, then the diamond, and then this big tower. Don't forget you guys can obviously mute it. Okay, so go through the door, then the diamond, and then this big old tower. And we're going to learn a little bit about carbon. So I kind of referenced carbon earlier in this unit, or in this lesson where you guys talked about just why, I mean, if we put atoms together differently, why do they cause such different properties? So one really great example here is carbon is what makes up diamonds, but it's also what makes up graphite. And graphite's what we use in pencils. So if we were to take and use diamond, which is again the same chemical structure as graphite, and we were to put that into a pencil, it wouldn't have the same effect. We couldn't just write across our paper and leave a trail of diamonds. Okay, as cool as that would be, diamonds are super hard, the hardest substance that we know of, versus graphite is super soft. That's why when you run your pencil over paper, you guys leave a big old mark or a line of graphite, is because it sheds right off. So you guys are going to learn a little bit about why that is. If they're made of the exact same thing, why do they behave so differently? So you guys will click to enter, and then you guys can kind of look at this as a little building where we have different levels on an elevator right here. So follow the directions and where it tells you to go. So it says level 2. Give 2 examples of where carbon might exist or might be used in and on Earth. Okay, so you guys would go down to level 2. And once your elevator reaches it, you're going to have a chance to learn a little bit about carbon. So carbon is an incredible element that is found everywhere. So you guys can kind of click to advance. Each carbon atom can bond with up to 4 carbon atoms. So keep reading through those until you guys have answered those questions. Then move on to level 3. What are 2 examples of amorphous carbon? Level 4, how are the carbon atoms arranged in diamonds? And how does that affect the properties of diamonds? So again, this is what I was just talking about with diamonds being so hard versus level 5 is graphite. How are the carbons arranged in graphite? And how does that affect the properties of graphite? Remember, graphite is very soft. Okay. Finally, you guys are going to learn a little bit more about atoms, molecules, and how we can have some different substances. So you guys will right-click this little article here in Amplify, and you guys will go in and read and or listen to this article. Looks like this. It's called Atomic Zoom In, comparing substances at a very small scale. So again, you guys will see that reference of diamonds, how they are structured. One of the best parts about this is how atoms make your orange juice smell good and your socks smell bad. So the same smell that we put in orange juice to make it smell good versus the same smell that makes your socks is the same chemical formula. They're just arranged differently. So you guys can go ahead and read about that. Read a little bit about diamonds. Okay, and then go ahead and answer this question here. How do the types and numbers of atoms that repeat to make up a substance affect its properties? So how do the types and numbers of atoms that repeat to make up a substance affect its properties? So answer that question. And if you find that you guys have more time than the 100 minutes in class, so you got done a little early, you guys can go ahead and play this periodic table memory game. Follow the link right here in Nanospace. That should already be open for you. If not, it's back up on slide 11. And you guys are all done. You can go ahead and hand it in, and I hope you're having a wonderful day. I'll talk to you soon. Bye.